All right, folks, let's get after it with page 1 here of the practice problems for the Chapter 8 test. Before we get started here, I just want to highlight again, I know I've said this before, but I want to talk about how important it is with the relationships in this chapter. Everything with respect to polygon angles involves these three pieces, one of these three pieces. We're either talking about the number of sides, we're given the number of sides, we're given something about the sum, remember that's the Greek letter sigma, of the interior angles, or something about the sum of the exterior angles. And depending on what you're asked to solve, depends on what information you're given. And you're not always given a picture of the polygon. So I wanted to talk about that very briefly here. So I just have a generic polygon drawn here. Let's see, it's got 1, 2, 3, 4, 5. It's got 6 sides, so it's a hexagon with 6 sides. And right here, this is one interior angle. The exterior angle that corresponds to that would be the angle that I would get if I were to extend one of those sides. So that would be the exterior angle. Now, it doesn't appear to be a regular polygon because not all the sides and angles don't look the same. So that's all I can say about this specific polygon. I know that I have a number of sides is 6. I've got an interior angle sketched out here and an exterior angle here just to kind of illustrate what that looks like. Many of these problems we're going to do, in fact, all the problems on this first page, you're not even given a picture of the polygon. You're just told in words what the situation is, and from there you have to solve it. So let's go ahead and jump back out here and go back to the example problems. Problem number 1, regular polygon has 14 sides. Stop right there, folks. I want to highlight that word anytime I see it because it has special meaning when we're working on polygon problems. So we have a regular polygon with 14 sides. So I'm going to keep track of that. What is the sum of the interior angles? Well, that's pretty easy. We have a direct formula for that. We plug in n equals 14. 14 minus 2 is 12. We do 180 times 12, and we get 2,160 degrees. And again, that represents the sum of all 14 interior angles for this polygon if you were to add them up. Now, we're not asked anything else, even though it's a regular polygon. That's all we're asked to do is find the sum of all 14 of those angles. Let's move on. Number 2, a regular polygon. There's that word again, folks. Regular polygon has 16 sides. What is the sum of its exterior angles? This is straightforward. This is true of all polygons, no matter how many sides it has. The sum of the exterior angles is 360 degrees. One thing to keep in mind here, folks, is to just think about whether or not your answer makes sense. Are you asked for a single angle measurement, or are you asked for a sum of a bunch of angle measures? If you have a smaller number, then hopefully you were asked for a single angle measurement. If it's a larger number, like I would call this a pretty large number right here, then hopefully that's the sum of a bunch of angles. Even though 360 is not a super large number, it is the sum of all the exterior angles. If you're ever asked for the sum of the exterior angles of a polygon, you come up with something bigger than 360, you need to check yourself because you made a mistake. All right, let's jump into number 3 here. A regular polygon has 18 sides. What is the measure of each interior angle? Well, here's that word again, regular polygon. And we've got n equals 18. What is the measure of each interior angle? Well, I know that the sum of the interior angles is equal to that 180 times n minus 2. And here's one of those properties of regular polygons. All the interior angles are the same. So if I take that sum and I divide by n, that'll give me the measure of each interior angle. So now we just plug in n equals 18. We do 180 times 16 divided by 18, and you get 160 degrees. Again, ask yourself, does this make sense? Could I have a single angle of 160 degrees? An interior angle? The answer is yes. So that answer passes the sniff test. Let's move on to number 4. Oh, there's that word again. A regular polygon has 12 sides. What is the measure of each exterior angle? Well, I know I'm going to use a similar strategy to what I did in number 3. except I'm going to go to a different formula. I know the sum of the exterior angles has a formula. And because it's a regular polygon, all of those exterior angles will be the same. So I can take the sum of all of them, all 12 of them, divide by n, and I'll know the measure of each exterior angle because it's a regular polygon. Well, the formula for the sum of the exterior angles is really easy. It's just 360 degrees, and I divide by 12 because n equals 12, and that gives me an answer of 30 degrees. We're cooking with gas here, folks. Question 5. 4 angles of a pentagon add up to 427 degrees. Notice that there's nothing in this problem but a regular pentagon. So all I know as far as a formula is this. I know the sum of the angles of this pentagon have to equal 180 times n minus 2. And 4 of those angles, 4 of the 5, because n equals 5 here, 4 of the 5 add up to 427 degrees. What is the 5th one? Now let's just call it x. So the 4 angles plus the 5th one are going to give us our answer. Let's go ahead and substitute n equals 5 to the left-hand side. So we have a 180 times 5 minus 2 is going to equal 427 degrees plus x degrees. 5 minus 2 is 3. 180 times 3 is 540. And we subtract 427 from both sides, and we get x equals 113 degrees. And let's ask ourselves a question. Does that make sense? Can we picture an angle, a single angle, the 5th angle of a 5-angle polygon being 113 degrees? And that is a plausible answer, so we're going to go ahead and move on. Question number 6, probably the hardest one that I've asked you to do on this side. What is the area of a regular, oh, there it is again, let's highlight it, folks, a regular Pentagon with side lengths of 4 inches. If you recall, when we worked on problems like this back in the notes, what we did was we looked at a central triangle, and I'll call this our central triangle. And we said if we could find the measure or the area of that central triangle and then multiply by n, in this case, n equals 10 because we have a regular Pentagon. So if we can find the measure or the area of one of the central triangles, we can multiply that by 10 and get the area of the entire regular polygon. But we need to do a little bit of work here. The first thing we need to think about is, well, how are we going to find the height of that triangle? We're told that the side length of the regular polygon is 4, so that's this dimension. We know that when we drop the perpendicular down, that's going to split this into 2 congruent pieces because every central triangle in a regular polygon is an isosceles triangle because these 2 dimensions are the same. But we're stuck here unless we know an angle measurement. This entire angle right here is going to be equal to 360 divided by n. So that's 36 degrees, which means that when we cut it in half, this angle right here is 18 degrees. So I can use what I know about right triangle trigonometry to solve for h. Tangent ratio equals opposite leg over adjacent leg. In this case, the opposite leg is 2 and the adjacent leg is h. We can go ahead and rearrange this and we get h equals 2 divided by the tangent of 18 degrees. And that's approximately equal to 6.155, and it's going to be inches because this problem is in inches. Okay, so now let's talk about the area of the central triangle. So the area of that central triangle, and again, I'm going to highlight that for you. That's this entire triangle right here. That has an area of 12.31 square inches, but that's not our entire shape. We have 10 of those, okay, because we have a regular Pentagon. I don't know, folks. I don't know how you feel, but I don't like green there. Let's go back to red. So we're going to do 10 times the area of the triangle we just found. That's going to be 10 times 12.31 square inches. We don't even need a calculator for that. We just have to move the decimal place, the decimal point one place. That's 123.1 square inches. And that'll be the area of that regular Pentagon with a side length of 4. Okay, folks, we're going to shut down page 1 here and start page 2 in just a second.